Hello, geometry students. This is a quick little video to explain how to find the area of a regular shape, a regular polygon, I should say. So this is a polygon here. Let me count its sides. 1, 2, third side, 4, 5, 6. So this is a hexagon. So anytime it's regular, that means that all of these sides are the same length. So side 1, side 2, side 3, side 4, all these sides have the same length. So in this case, each side is 8 inches long. Well, the plan is, how do you figure out the area of this shape if you only know one piece of information? Well, the plan for this is to do this. Break the shape up into triangles. Since this shape, a hexagon, has 6 sides, it has 6 triangles. And you're going to see in a little bit that I'm actually going to break it up into 12 instead of 6, but it doesn't matter. You can use 6 or you can use 12. But I like 12 better because it's a little bit easier to manage in my mind. The second thing you're going to do is you're going to find the area of each of these triangles. So in this case, I'm going to find this area of this one right here that has the 8 on it. Once I find the area of that triangle, which should be relatively easy, you just multiply by how many triangles you have. In this case, 6, or in a moment, you're going to see that I'm going to break this guy up in half into this guy. So each 6 triangles is actually going to be broken up into 2. So I'm going to have 12 triangles, and I'm just going to find the area of this triangle right here. That's the plan. It's pretty simple, pretty straightforward. The thing that you want to take note of is that these triangles, if you drop this from the middle, you drop this side down to this side, it is A, perpendicular, and B, it cuts this 8 into 2 equal parts, cuts it in half. So here's my plan. The very first thing you need to do is you need to figure out, well, how many degrees is each one of these? These are called central angles. Well, since a full, complete rotation around is always 360 degrees. So if this is a regular hexagon, all of these are going to be equal. So if there's 360 degrees in a full turn, and there's 6 triangles there, if I divide each by 6, you're going to get each one of these little angles is 60 degrees. So that's kind of my plan here. So if you look, I'm going to put this guy right over here, which overlaps into that triangle. I'm going to move this down. I'm going to be looking at this yellow triangle that has a height of this red line. That is my plan. So now let's execute the plan. The very first thing I need to do is, if this bigger triangle is 60 degrees, then this little guy is 30. Let me go back for a second, and let me just draw in here that if your plan is that each one of these is 60, I am cutting that 60 in half, and then this part of my triangle right there is going to be 30. So you can kind of see that better in this next picture right here. So this is 30 degrees. So I'm going to find the area of this, which is actually pretty simple. And then I'm going to multiply by 12. Now, if you want to find the area of this whole one and multiply by 6, you can do that too. It's either one is your plan. So thinking about my plan, a triangle formula is 1/2 base times height. And I outlined this triangle in red. So since the whole distance from B to C is 8, half this distance is 4. So the base of my triangle is going to be 4. So the question is, well, how high is this right here? This dotted line right here on this side is my height, because remember, heights and bases must be perpendicular. So 2 different methods. Method number 1, since it's a 30 degree, 90 degree, this must be 60. So it's a 30, 60, 90. I could use my 30, 60, 90 rules, or I could use trig. I'll actually do them both just to give you a little review here. So I'm going to start with the 30, 60, 90 because that always goes faster for me. So if you know that your formula is this side is L, the short side's L, the hypotenuse is 2L, but if you look, I don't really need the hypotenuse here because this is not part of the perpendicular side, so it's not the base, nor is it the height. But I do need this side, and that's L times the square root of 3. So if the short side is 4, and this side is L times the square root of 3, and L is 4, this side is going to be 4 times the square root of 3. Now I did this in my calculator, and I got 4 times the square root of 3 is 4 times the square root of 3 is 6.928, and I'm going to round that to 6.9. So 6.9 is going to be this side, which in my picture is the question mark side, 6.9. So that's my height, 6.9. Well, what's my base? My base is already 4. So then I'm just going to do 1/2 times 4 times 6.9. Now, if you wanted a little trig review here, you could certainly use trig. This side over here, I'm going to put this in purple so you can see my work here. This side is the opposite. This side here is the adjacent. So opposite and adjacent is TOA. So the tangent of an angle, and then my angle is 30 degrees. That equals the opposite. Opposite of the 30 is 4. 4, that's the opposite side. And the adjacent side is my unknown. That I called it x. I could have also called it h for height. And then I need to solve this. So since the x is in the bottom, I'm going to multiply both sides by x to bring it to the top. And then I'm going to switch by dividing by tangent. These two guys just basically switch sides whenever you have an x in the bottom. So the x comes over here. Boop. The tangent of 30 goes on the bottom. Boop. I type into my calculator 4, division sign, tan 30, enter, and I'm still going to get 6.9. So it doesn't really matter. I feel like this way goes faster, but I know a lot of you like trig, so that way will go faster too. So now here's the plan again. Once I'm going to change to a highlighter here, and I'm going to highlight this triangle in blue here. Once I find the area of this, which is 1/2 times 4 times 6.9, I'm going to multiply that by 12. Now, if you really wanted to, you could actually, just showing you an alternate way to do this, you could actually change this 4 here to an 8, because this is 4 and this is 4, and that would be 8, and then you'd be doing this whole triangle. So if you did that, there's nothing wrong with that, then you just multiply by 6. But I'm doing this inside the light blue one, so I'm going to multiply this by 12, because I have 1 triangle here, 2 here, then I have 3, 4. I'd split this down the middle, 5, 6. I'd split this down the middle, 7, 8. I'd split this down the middle, 9, 10. And I'd split this down the middle, 11, 12. Basically, this whole thing, all of this is review for you, except you're just multiplying by the number of triangles. So I calculated this on my calculator, and I got 13.8. And now I'm doing the 12 since I did the 4 and I didn't do the 8. Then I take this 13.8 and multiply that by 12 of those triangles, and I get 165.6 inches. Now, a couple quick comments. This is a difficult question without me guiding you and giving you tons of practice. All I care about that you understand on this problem is that you kind of know how to do these 3 steps here. Break it up into the number of triangles, find the bases and the heights of these triangles, and then multiply by either, in this case, it's a hexagon, so 6 or 12. If I did a pentagon like this, it would be the same kind of idea, except I'd be breaking it up into 5. That's how you do a regular shape here. It'd be 5 triangles. 1, 2, 3, 4, 5. And if it was an octagon, it would be 8, etc. But you don't really have to know that. I just care that you understand the system. And if you understand the system and can kind of just explain that, you're going to get full 100% credit on the next test. But I am going to give extra credit for any of you that can complete the calculations of this. I'll give you a practice problem and we will go from there. Thank you so much for listening, everybody. I hope this all makes sense to you. Have a good day. I miss you all.